Hi,
good afternoon. I think we're live right now, a little bit later. So it's 5:03 and it's time for us to start with this live presentation right now. And before I give the word to Bianca Ximenes, she's our guest speaker tonight, I'm first going to introduce a little bit about our group. I'm going to introduce about the Women Techmakers Amsterdam. So our group is part of the GDD from the Netherlands, and we're also part of the Women Techmakers. So Women Techmakers is a global initiative supported by Google. And our goal is to provide visibility, community, and like resources for women that are in technology, but also for women who are planning to start a career in technology. Here in the Netherlands, we organize events, we organize webinars, workshops, and we share useful resources, useful content for everybody that is interested in technology. So everybody is welcome into our events and, of course, into this webinar today. Next slide, please. Yes, so you can find our group and all about our activities and our events and news in social media. So we are in Instagram, we are on Twitter, Facebook, LinkedIn. We have a group on Meetup as well. And most recently, we have a Discord channel. So if you would like to start discussions and share about your own resources that you find interesting with our community, feel free to join us on Discord. So here on the screen, you can see all of the links and how you can connect with us on social media. Next slide. Okay, so we are a group of 5 girls who organize the Women Techmakers. So it's me, Virginia. I already introduced myself. Then we have also Yannick. She's over there. Natalia.
Hi.
Monica.
Hello.
And Manitza, who is our lead, but she's not here with us today into this event. And here on the screen, you can also see our personal Instagram handles. Feel free to connect with us over there if you want to talk with us personally. And next slide, please. And just to ask you, please, if you have any feedback for us, for the Women Techmakers Amsterdam, please feel free to contact us via this form we have. Also about this event or future events, please feel free to contact us. And now I would like to introduce Bianca Ximenes, who is our speaker for today. She's here, she's all the way from Brazil, and we're very happy to receive her today to give her presentation. She's a GD expert in machine learning, so we're super honored to have you here, Bianca. And please, you have the word now, and you can make your presentation. Thank you so much.
Thanks, Virginia, and thanks everyone from WTM Amsterdam for the invite. I'm very happy to be here. So let me see. Today I'm here to talk about how to design human-centric AI applications. And so there's a lot to talk about in that sense, but we'll try to be very, very specific in the next half hour so we have a lot of time for questions in the end. So this is a talk based on the Google PAIR team playbook. The PAIR team is the people and AI research team in Google, and they're part of the Google Brain team that works with AI. So last year, during I/O, which didn't happen this year because of the pandemic with COVID, they launched a guidebook trying to address very important questions and issues on how can we build better systems that have AI embedded in them. Because as you're going to see, hopefully today, it's a little bit different than what we're already used to when working with software systems. So this is kind of weird, but there are 6 chapters and they build on top of each other, and that's the order is like kind of a zigzag. But I really recommend you read it. And I found a lot of fun. I helped review the chapter on explainability and trust, which is the 4th chapter. And yeah, so if you want to log on and at pair.withgoogle.com, you'll find there's a lot of like, you can give feedback on everything that was done, and your feedback is very important to us. So I don't work for Google. I'm just a Google developer, expert on machine learning. And as I help them, I say to us because I also helps doing it. But it's mostly for Google. It's mostly important for Google because they're still working on it and they're still translating to other languages, not only English. So the first thing like today that I would like to ask and think about is what is a mental model, right? You can see like back here that we have a chapter entirely on mental models. And so what is that? What is a mental model? So I brought a story to tell you. First of all, this is a girl I met when I was at an event. I was gonna give a talk, and the event happened at a mall, a shopping mall. And I met this girl. Her name is Letitia. I was inside one of the bathroom cabins, and I kept hearing her saying, "Look in the mirror. It's underneath the mirror. Just no, don't no. Look under the mirror. It's underneath the mirror." And I was like, "What's going on? Is that like some kind of apparition or something? What is that?" And she didn't stop saying to look under the mirror. And when I left the cabin, I started trying to check what was going on. And this is what I realized. She was trying to help people out because whenever they finished washing their hands, they couldn't find the hand dryer, which usually is like by the wall. I don't know how bathrooms are in Amsterdam, but they're usually not so different from one another. So people would go there and they would expect to find a machine. You can even see the cables and the outlet and everything, but the machine isn't there. So then people would just walk out of the bathroom with their hands wet. And Letitia is an overachiever, and she didn't like people leaving with their hands wet. So she just kept saying, "Hey, underneath the mirror, you have like paper towels," right? She didn't say paper towels. She said, "Look underneath the mirror and you'll find the answer to what you're looking for." So yeah, I took a picture so you can see clearly that the paper towel is there. But whenever you're looking, like whenever you're washing your hands, it's really hard to see because it's really, really way underneath the mirror. So they had even to put these little tags of like paper towel everywhere to try and help people see that the towel was there and they could dry their hands. But the thing is, this is a very well-established mental model because if we have to think very carefully about everything we do, we wouldn't leave our beds in the morning, because there are so many things we have to do, so many things we have to think about. So we just go with the flow in many ways. We just go like automatically because we already know what we have to do. So it has a lot to do with muscle memory, with mental models, with like common flows we're used to. So then even though we have the paper towel tags there, people are not ready at that point to receive information. Like they're not looking for information now. Like they can see maybe the ad, but they're not looking for information telling them on where are the paper towels and where to dry my hands. This is way out their mental model, which is really a silly little thing, but it can cause a lot of distress when you're not used to it. So nowadays, I think the bathrooms are starting to change. I know that the Google corridors in London, they have the same type of paper towel underneath the mirror. And I've seen that happening in a lot of different places. Maybe that's a new architectural trend. But until we're used to it, we're bound to have problems because we're resetting mental models for people. So people would say that all the time when they finally found the paper, they would be like, "I am so stupid." And I heard a lot of people saying that. And I hung out like for 20 minutes in the bathroom just trying to see like the commotion for the paper towels. And people would be like, "I am so stupid." Everybody was like, "I'm so stupid because I should have seen it. The sign is right there. So why didn't I see it? I'm so stupid." And that's it. So let's try to bring a mental model in context for AI, right? We have here two different facial recognition systems, Gamma and Sigma. They're obviously a little different, right? Like one of them has a confidence ratio, and the other one just like labels the people. And I spent, I think, the year of 2018 making these questions, making quizzes with people, like asking people in the audiences of the talks I gave, which system do you think seems more trustworthy, the gamma system or the sigma system? And I had a very good idea of which one I found more trustworthy. But these were the typical answers. Usually people would be like, the gamma system is 20, 40% more trustworthy. Like 20 to 40% of people said it was more trustworthy. And 60 to 80% of people said sigma system was more trustworthy. So it's like, why does that happen? Like, why do you think this other one is more trustworthy, right? And people would be like, well, first, that would be like really weird questions like, well, if the sigma system can identify Oriental people, it's so much better because us Occidental people are so much different from one another. So this is just like typical prejudice, because for Oriental people, Occidental people also look the same. This is a cognitive bias where we more easily identify people that are from our own ethnic groups. Yes. So that has nothing to do with the system. Like for a facial recognition system, it isn't harder to identify Oriental or Occidental people as long as we have all provided quality information, right? As long as we have provided quality information, quality training data, it's as easy as pie, like both of them. So, and people would be like, well, the sigma system, it is not unsure of the labels it's put in there. Like for Gustavo and Guilherme, which are two like Brazilians and look extremely different from one another, it's not even 100% like sure of who they are. They say like, well, this is Gustavo with 67.3% of confidence, and this is Guilherme with 74.5% of confidence. And these other ones, it's not like that. Like Yangxing, it knows it's Yangxing with 100% confidence. And I was like, no, that is not true. We always have a probability connected to that. And people would be very, very amazed. And it's not like random people, it's like software engineers. Everyone would be like, well, if it's labeling and it has no confidence ratio, this is for real. This is like something, it is sure, it is 100% sure. And that doesn't happen. So this is the first break on mental models when we're working with AI, because we have two different types of paradigms when we're working with computing, which one is the deterministic paradigm and the other one is the probabilistic paradigm. The deterministic we're all very, very familiar with. Is what we find in cell phone menus. Like you press a button and you have that specific answer coming out. Like if you press 2 + 2, it'll always be 4 and you don't have to think about it. So people get used to that. Like whatever the machine says is correct in that sense. And they're not used to having a machine which is not so sure about what it's saying, you know? So whenever you're working with machine learning applications, AI applications, and I really wanted to take that in your heart with you tonight, which is if you're working with AI, the results are always probabilistic. We have no certainties in AI. If whatever we do in an AI system is 100% sure, then it could have been solved with traditional programming and is not an AI problem, you know? So people have that expectation of anthropomorphic intelligence as well, which is something slightly different. And I really like that quote, which is from the IEEE Ethically Aligned Design is a manual for ethically building AI systems that was also launched last year. And they say there lies a danger in uncritically attributing classical concepts of anthropomorphic autonomy to machines. Anthropomorphic means human, right? Related to anthropos, related to men, related to us. So we run the risk of assuming economic and political dimensions that do not exist. Gender and popular discourse may not share in the same nuanced understanding. Like I work with AI every day. I'm a product manager for AI at Guppy, is the company I work for. And I know that AI does not comprehend a tenth of the things people expect it to comprehend. So it is not 100% sure. It is not 100% correct. It is always probabilistic. But people and our users, they do not understand that in general, especially because they keep being fed like pop culture, and they keep being fed things that show super intelligent AIs. And these are like our dreams about AI. We dream of AIs that are corporeal, they're sentient, like they know who they are, they feel things, they understand feelings, they can learn with data in the open world, just like we humans can, and not a training data set. So people are not used to thinking of AI like that. By the way, this is a great movie. If you haven't seen it, this is a great way to pass time in the quarantine. But this is more like what AI really is. And this is a model, which we call boosted trees, is a complement, is like a mashup of gradient descent and decision trees. And it's one of the most used, the most ubiquitous AI models there are today. So in artificial intelligence for now, and probably for a long time still, it's simply, and I say simply because I know it's hard, like technically, but there is really nothing more to it than that. So it's a set of techniques of mathematical optimization in broad scale using tremendous computing power. And it's really hard working with advanced methods and statistics. And it's not because of the reason why you're thinking. It's because, oh, it's really hard working with maths. It's a lot of numbers. It's so complicated. It's not because of that. It's complicated because people are usually like in two spheres that they come together, but not always. So one sphere is the wow factor. It's like, wow, I can't believe you did that. Wow, this is so cool. And wow, this is so interesting. And it's like the system is reading my mind and this is perfect. But the other way around also is I don't really understand what's going on. And that kind of sucked. Like the system didn't get it right. So we also have the meh factor, like, meh. So it's a very thin line we have to run to go from the meh factor to the wow factor. And how can we like keep changing from one to the other, right? How can that happen? So I'm going to give you like some, okay, so this is what happens when you're stuck in the meh factor. So the user, they tend not to blame themselves. They blame the system because the system is supposed to be super intelligent. The system is supposed to be sentient. The system is supposed to know everything and to learn about everything. So whenever it doesn't, because it's probabilistic, because it will make mistakes, your user will be like, this system is so stupid, and they will uninstall your app, right? So this is not what we want. So let's try and talk about an example. This is an app I haven't used myself, but my father, he's really keen on gardening. So this is an app called PlantSnap, and it tells you, it identifies flowers, plants, and trees with a snap of a photo. So let's suppose, like for the sake of the argument, how it happens today, like with PlantSnap and everything else, like every other kind of apps that identify stuff. The app will tell you, well, this is an orchid. And if it is right, then you have a wow factor, right? It's like, wow, I pointed and the app really said that this is an orchid. Like for me, it doesn't make a difference because I can't tell my flowers apart. Like for me, they're all the same. Like I can maybe tell you what a rose and a daisy is, but like apart from that, everything is very weird for me. But well, it says it's an orchid and I have a wow factor, like if it's correct. But if it's not correct and I'm an expert like my father, it will be awful because it'll be like, oh my gosh, of course, that's not an orchid, that's a daisy. And this system is so stupid and I'll delete this app, right? So this is what usually happens. So how it could happen, right? I'm here to show you like a different view on how we can build our systems with AI. So imagine if you say, well, this is an orchid, and you have a second prompt. It's like, do you think we got it wrong? So tell us what it is. And then you can change a little bit of the person's like, oh, okay, the system is learning. And it is so important that our user knows that the system is learning little by little. And they can also help you identify and label the correct pictures. So this is so good for model tuning and for incomplete data, because you'll never have a complete data set. And all AI systems need data to be trained. They cannot learn in the open world. So this is very good for model tuning. And whenever a user can tell you like, oh, this is not an orchid, this is a daisy, they're automatically labeling your data for you, which is so good because, for instance, just so you know, like this month, we are having to label over 20,000. I work at Guppy with recruitment and selection. So we're having to label manually like 20,000 different types of prerequisites and responsibilities. And this is so time consuming. And you can even make your user work for you while they also learn that the system is learning. So everybody wins in the end, you know? But this is not enough. Like, more issues lie ahead, because users, they push boundaries, you know? So you know how people will come up to their assistants like Siri and Alexa and Google Assistant and be like, I love you. And they have to enter something, you know? So Google Assistant will say, oh, you're clearly pretty awe-inspiring yourself. So this surprises you, and this causes a wow effect, right? So let's see an example of how users push boundaries. Like, my dad does that all the time. So he has an app that identifies plants, but he'll point it at the dog because he wants to see what the system does. And every user is like that. The user really wants to break your system all the time. I think that never changes. Like, if you're working with AI or software engineering or I don't know what else, users always try to break your system. So my dad will point it at the dog. And imagine if it said, that's a yellow rose, right? Because, like, according to the data it has, the most similar thing is a yellow rose. You'd be like, Math Factory, this app sucks. I'm going to uninstall it. It has no idea what it's doing. Or maybe you have a good laugh, like, he thinks it's a yellow rose. This app is so dumb, which in both cases is not a really good thing, right? But imagine if the app says, and it usually says that when it doesn't recognize what's there, it says, sorry, that's a tough one. But remember, we only recognize plants, leaves, and trees. We can now have a wow factor. It's like, wow, I tried, and the system, like, it didn't exactly recognize what I put there, but it recognized that it wasn't one of those things, you know? So now I have a wow factor. And this is so important because I'm calibrating trust in the system. And trust is so important in AI systems. It's important that people know that they can be wrong, so they question it. And it's also important that they build the learning together. So I'm going to give you an example of a friend of mine. He's also a GDE for web, and he works at Tinder. And his name is Marcos. And I know I can talk about that because I already told him. I always tell his story because I think it's so funny. But Marcos is really like, he's really results driven, you know, he's really focused. So he wanted to do like his profile. He wanted to make his profile in a way that he maximized the number of likes in his profile. So he wanted the most matches. So he started like changing the order of the pictures and changing the text of the bio and changing a lot of things. But at Tinder, you also have a space to tell where you work, right? And he was telling me like, Bianca, I was really at a crossroads because I didn't know if I should tell people I worked at Tinder or if I shouldn't. So then at first I decided I wouldn't tell them and see how that went. And he got a whole lot of like matches, you know, a lot of people match with him. But at some point when you're like talking to people, people will eventually ask you where you work because that's just how life is. People want to know where you work. And then he would have to tell people, no, I work for Tinder. And it would be completely disgraceful because people will think that he somehow cheated the system, he manipulated, he matched, but it wasn't really a match. People would be so suspicious and they would not trust him. And in the end, like pretty much every single chat and match he had would go sour. and nothing would happen. So then he said, well, so I just decided that it would be best if I upfront told him in my profile that I work for Tinder, because I get a lot less matches, like maybe a third of what I used to get. But at the same time, whoever's here knows what they're here for. And maybe like, of course, I can't change the algorithm. I can't beat the algorithm. I can't hack into anything. But people will think that. And like, if people know I already work for Tinder, they come on board, like, and they're okay with that, you know? So we have a nicer conversation, and none of my like maybe future relationships will go sour. So what he does is he's calibrating trust, because he's upfront telling people what he is and like what he can do, what he can't do, you know? Like, I work for Tinder, and well, that's just how it is. So let's just see, like, to finalize, we're getting to the final moments of this talk, but consider this example. People always ask me, well, where can I download this app? I really liked it. This app does not exist. It was conceived by the Google Pair team as an example, because as it is, we do not have any products that work with AI that are completely adhering to these good practices. You know, it's really hard building products with AI. It's something new. It's not that AI is new. AI is not new. AI has been there since the 50s. But building products as we have with AI is something very new, and we have to learn a lot of things. So this is an app to illustrate what we can do and what we should do when we use an AI, okay? So the first thing we have to do is set expectations. Just be like Marcos, you know, like be like, I work for Tinder. So like tell us what your app can do. So for instance, suppose you log on the app and it says like music for your run, no playlists yet. You can find songs or not now. You can like skip it and do something about that later. Of course, they exaggerated because everything there is red, right? But this is common. Like it's that happens. You log in and people say like no playlist, find song, and you're like you don't know what's going on. Like, well, okay, if I go find songs, what will happen about that? Like I have to assemble my playlist and like song by song, what do I have to do? And it's different from that. For instance, it's like music for your run. Add 3 songs and we'll make playlists for you. So now I know what I have to do. Like I go find songs, I only have to find 3. And if it's gonna make playlists based on these songs, I should select songs that have to do with my current mood, right? But I don't have to pick out one by one. It will generate some kind of playlist for me. So I know what I'm doing and why I'm doing it, you know? So the first thing is set expectations. The other thing, which is different than software engineering in general, at least, I worked before as a PM for digital products in general. And we would try every time we could to turn a bug into feature. So we would never say that we can't do something, right? That's just not what we do. But in AI, you should say what you cannot do because of that relationship of trust. So imagine you have that. Let's see first the one to the left, which is red, is like night moves. Be careful on your evening run. And you're like, okay, the system is nice. It's worried about me. Let's go. I'll start running. It's completely different from the situation on the second, the green screen, because it says night moves. Be careful because it's after 6 p.m. and our run route recommendations don't include streetlight data. This informed me of what you can't do. You're optimizing a route, but you cannot be like really reliant. I can't really rely on you to recommend a route for me when it's dark, because you cannot take street light into consideration. So maybe you send me into some really weird dark place, right? So this is different because it prompts me to make different decisions. One thing is saying, be careful on your evening run, and I don't know why, so I'll do it anyway. And the other thing is, be careful on your evening run because I might be sending you somewhere you don't want to go at this time, you know? So I give the human, the ability and the opportunity to choose what it wants to do. The other thing is explain predictions. So for instance, imagine I sprained my ankle and I'm trying to get better, right? Excuse me. So I have to do a recovery workout, and they will say, well, we picked this workout for you and we have adjusted your normal route to aid in your recovery. And I'm like, oh, okay, but like, what exactly did you do, right? I'm not sure how you adjusted it. And it's different if I do it like that. Well, recovery route details. What has the system taken into consideration? It's given me a route with minimal elevation, with even surface, and it's set a slow pace. So it says it's 50 minutes duration because it's considering I'll take it slower. So then I know, and like, suppose that I know I want to challenge myself. I'm already feeling way better. So I don't have to run on even surface, or I don't need minimal elevation. I want something like I want to run uphill. So I have the option to understand again what the system's doing, and I to see if it fits what I want or if it doesn't. I also have to prevent context errors. For every single system, you have system errors, which are bugs usually, which we try to turn into features, and we have user errors, things that the users can get right. But with AI, we have another type of error, which we call context errors, and I'm going to explain that to you. So for instance, I picked a route and I got there at the beginning, like at the spot is marked. And whenever I get there, like as soon as I get there, the system just tells me, run started, you're in position for the next scheduled run, enjoy your run. And it has already started, like the run is already active. It's already timing me. But suppose that like I got there, but I didn't want to run, because I wanted to eat cake first at a bakery next door. And if I'm going to run, I might as well eat cake, right? Like I deserve it. So it would be so much better if the system would be like, well, you're in position for the next scheduled run. Can we start the run timer? And I'm like, okay, you can, or not now. Not now, you can't, because first I'm going to eat my cake and then you do it. So this is context error, because just because you're at the same spot, the system can be very intelligent and suppose you want to start right now, but no, you have to give the person, you have to give the human the chance and the opportunity to be like, well, I don't want to run right now. I don't want to start right now. This is where I want to start. I have something I want to do first, you know? So I always delegate to the human the final decision. I can help people, and this is what AI should do. They can help people, they can improve on people's abilities, they can improve on like giving information and options. But I at least firmly believe that people are responsible and people have to make their own choices. And I can't build a system that does not allow for people to make their own choices, right? And finally, something that you already know, which is show model confidence. This is the same thing we've seen in the Gamma facial recognition system. It showed you like how sure it was that this was Gustavo's or Guilherme's face. But we have that everywhere. We have that on Netflix, for instance. Like when you see a movie, it will tell you, oh, this is a 58% match for you. The problem is, I'm not really sure if 58% is something good or bad. Like I don't have a baseline. Maybe I like every movie that is over 50%. If it's 50% match with me, there's a pretty good chance I'm going to like it. Otherwise, if I'm really, really picky, no, I only like movies that are 90 above % a match for me. So 87% is a really low number. So the thing is, us humans, we don't really have a notion of what is a good number in the end. You know, so I have to show or should show model confidence. Oh, and remember that this is something very new because we've been using AI systems for a long time and they have never shown us their confidence. For instance, the Google itself, when you make a search on Google, it will give you a list of results. And every single one of that result has a confidence level on how similar it is to the search you made. But it has never told you about that. But it was made in like another time where people thought maybe that wasn't necessary. We didn't even understand what we were doing as a whole. But now we're trying to make systems that tell us what is possible. But there are better ways to show model confidence that go beyond showing simply the percentages. So for instance, you have here, well, I have here best matches for you. Like these ones really have to do with what you like doing. These ones are good matches. They're not as similar, but they're also good. And these ones I'm unsure about. I have I don't have enough data to say what it is about. Like if you really like it, if you won't like it. And I think that's really cool because it's not telling you this is the right answer. It's like, well, you have all these options. We think these are the best for you, but this is also good. And this I don't know about, but maybe like you have some kind of serendipity factor, right? Where you're not sure also, and you can go there and check, well, maybe I'm going to try to do something different today. And then the system will start gathering data on that, right? But otherwise, I'm always stuck, and I have all those problems. I'm sure you remember the Facebook scandals in 2016 and the Chamber of Echoes that we usually trap ourselves into when we use a lot of recommended content, because we don't have that serendipity factor. It's like, how do you feel about that? Like, would you like to read about that? Like, would you like to make that run? So it's not only giving you the best matches and things you're going to like, but it's also like things they're unsure about. So I think this is a great option. Another option, which we call end best, is like, well, this is the best route we found for you today, but we also have other recommendations. This like lowers a little bit of the serendipity factor. Probably I won't find anything new if I have a very specific like running pattern. But at least it's also not telling me, well, this is the way to go. Like, this is what you have to do. And you have the old and used, tried and true, the confidence percentage. But here it has a tweak I really like, which it says is a 93% run match. And it gives me two explanations. Like, it's urban running, like you're like running in the city. And it's a mix of turns and straight paths. So that is why this is such a high, it has such a high score and is recommended for you. So these are different ways of doing things. I think the first one is the ideal way, is the best way. I have never seen anything like that, especially as like, well, I'm unsure about that match, because people are still, and developers and AI engineers, we're still trying to prove that AI can do it all. But I really want to build and start building. I'm starting building in the company I work for, those systems where we admit that we're not sure about a lot of things. And this is part of working with AI too. So just as a quick review, you have to set expectations, say what you can't do, explain predictions, prevent context errors, and show your model confidence so people can make their own decisions, people can be informed, people can understand, and people can choose what they're going to do, right? That's what I at least expect for AI in the future. So we're not in some crazy AI dystopia where we don't have a say, we don't have a voice. AI just does everything for us, even what we don't want it to do. So this was a very, very quick cover of 3 chapters of the mental models, explainability and trust, and errors and graceful failure chapters at the Google Pair. You can go there. It also works perfectly on mobile. It's perfectly responsive, which is the least I'd expect from Google, right? But you can give feedback on mobile or on the browser. You just have to go there and check it out at pair.withgoogle.com. So thanks for your attention and thanks for being here today. And I think we're going to open now for questions.
Hey, Bianca. First of all, let me say that I really loved your presentation. Thank you so much for sharing your knowledge here with us and sharing what you're doing every day, your expertise. I think I really love your practical view on AI. I think you're working with applied AI, and that's not something that everybody does. And I love that you indeed, because I think much of our audience here maybe is technical, and they kind of say, okay, I know what is deterministic and probabilistic, but I think that most of the general users have a very indeed they ideal view of AI, and don't they? And I think they think that AI can do everything. And I love when you say that we need to set expectations, especially because we're making AI not for us but for the user. And at some point, the users are going to be interacting with AI, and yeah, we're gonna see like the user needs to get something useful out of AI, of course. Otherwise, there's no point in making AI at all. So I really like when you say that in the end about setting expectations and like really putting yourself in the place of the user and seeing what does he or she expect from AI. So I think that's really interesting. I get very passionate about the subject as well. So thank you so much for the for sharing with us all of the slides and the case scenarios. I think I see in the comments people really like them. So
That's
let
great.
me see.
Thanks for having
Yes.
me, guys. I really like
Yeah.
talking about it. You're so right. Like I'm really passionate about this subject, and I
Yes.
think we can make a big difference on it, like working together.
I think so too. So I think many people maybe never heard about the guidebook, and I think that's already a great resource that you're sharing with us. So
I think it's the
let's.
best resource, like for now. Like I'm doing a PhD on that, and I think I'm gonna have a lot of material like soon. But I think nowadays is the best resource we can like I've seen on that, like on trying to
Yes.
like apply and make it for the user. And just like you said, it's like, well, we understand what deterministic and probabilistic is, but like how can we communicate that to the user? This is the
Exactly.
major like challenge we have, I think.
Yes, exactly. Awesome. So I think we have time for some questions. We know we're very busy, right? It's the middle of the afternoon in Brazil.
Yes.
So here, some people are very active in our chat. And so playing with Prolog, I think it's Annie, she said there. She asked something about one of the user case that you told us. She asked, so the paper towel signs should be where the hand dryer usually is or not?
It would be best if they were, yeah, because at that point, I'm changing my model. Like I'm going. We have two types of systems. Of if I can recommend a book, is Thinking Fast and Slow by Daniel Kahneman. He was an economic Nobel, a Nobel for economics, but it's a really interesting book because it says we usually work on our first thinking system, which is very like reactional, which is like things I already know how to do. And the second like thinking system we have, it's more complex, and it's the one where we get really analytical. And when we're washing our hands, and we're in this first system, we're just doing things we don't have to carefully consider. So when I go there and my expectations is broken, then I change the module. I change the gear, and I enter the where did the machine go, right? Where did the paper go? And then I'm more prone to receiving information at the point. So probably they would have a lot more success if they put it there. Like the paper is now underneath the mirror. Like it's not ideal. Like the ideal thing is, I don't know, not messing up with people's mental models, but they would have a much higher success rate, most likely.
Yeah, that's true. Thank you. Okay, so we have one more question from Luvia Morales. Thank you for sending the question, by the way. So Sigma, I think she's talked about the models before, has more people and clear faces, but the other should be better since it's more difficult to recognize faces with beard, she's asking. What do you think?
This is interesting. Well, like everything in a facial recognition system is very real. Like is way related with the data sets, the training data sets you give the system. So it's usually more difficult to recognize faces with a beard because we usually do not train systems with peoples with full beards. And maybe that's even why the confidence ratio is so low, like it's on the 60s and 70s. But it's impossible to say which system is better because I don't know, like I'd have to train. I'd have to test actually on a lot of different things, like on a lot of different people from different ethnicities, from different genders, from with beards and with glasses, and I don't know. China is having great results with facial recognition with people wearing masks because of the COVID pandemic.
Yes.
Because they're starting to train the system to recognize people in spite of their masks, which is a little scary, but it's happening. And like as a whole, like the basics of the facial recognition is that you kind of draw a geometric net on the person's face, and you see like the relations of eyes and mouth, where the nose is, and the shapes. It's like as if there was a mesh on your face, like so. I can't say if it's better, but surely it is a complication. But if the system was well trained with a lot of people with beards, it shouldn't have a problem as well.
Yes.
It also, like, it always has to do with the kind of training data you give your model.
Yes, thank you. We have one more question. I think it's talking about the part that you talk about giving feedback, I think, to the model, right? So crowdsource is new by Google. How it will help AI or my smartphone?
I'm sorry. I don't think I understand. Like,
I think he means like when you are given the chance, the user is given the chance to provide feedback. For example, you gave the example in the app of the plants, right?
Yeah.
So the user can tell if it's right or wrong. And I think like Google or some other companies are trying to crowdsource the labeling. So if it's wrong and then you give feedback, how is this gonna help? I think that's his question.
Okay. Your smartphone, I'm not sure, like, but they can make more robust systems and put them in your smartphone, which is you're gonna have more powerful stuff on mobile. So I think this is like the big deal. But how it will help AI? AI for most, like we have 3 types of machine learning / deep learning things. I don't know if I should get into that, like if I'm going to make it to get into that much detail, but we have supervised systems, like supervised training. We have unsupervised training, and we have reinforcement learning. So a lot of things we do rely on labels, and a lot of things that AI does relies on labels. So if we're crowdsourcing labels, we're going to have more accurate AI because we're going to be able to expand our data sets. Again, it will go back to like the system is as good as the data it's fed, So if I have more people labeling things, I'm going to have my AI understanding and recognizing more things correctly, So this helps AI a lot, and in turn, it helps you because you're going to have a more accurate, more robust systems, even on your smartphone, I think.
Yes, I agree with you. I think you can maybe make a more accurate and robust model when you crowdsource, but maybe you might be adding a lot of biases as well, because people have bias, but that's how we are, I think. But I agree with you.
We can have another talk on biases.
Yeah.
I just was talking about that, yeah. But like just before we go into this question of Sanvente, I think we're not able to train models now on our cell phones because it requires, like, as I said, AI is broad scale mathematical optimization with huge computing power. Yeah. And as good as our computers and mobiles are, we have to use like TPUs and GPU servers to do that. Yeah. So we can label on our mobile and send it back, like send the label back. Then they will train the model and send it back to my cell phone. So the change is not immediate, but it's better when I send the information and I label more things and I expand data sets. This is a great way also to deal with bias, for instance, because facial recognition systems are really good at identifying men's faces, and especially white men's faces. But dark women they are very poorly identified. So if
Yes.
we were to label more, be like pointing at our friends and be like, of course, do that with caution, but like with their permission, but like point at our friends and be like, well, this is a female from this ethnicity, then the systems will get better and will be less biased because I'm giving more examples,
That's
So
true.
crowdsourcing is good because of that, because the developer has a bias, even if they're not aware of it. We all have. It has to do with our mental models. It has to do with our simplification of the world. So if I give the opportunity for crowdsourcing and labeling and bringing in new information, I'm making the system more open.
Exactly. Nice. So
So
we have this question from Sam. He asks, how do you try to manage people's expectations? For example, when you're making a pitch, because you try and tell them that your AI is possibly very flawed, they immediately move into the me sphere, the man sphere, right? Like it's hard. I guess it's hard to tell about your flaws when you're trying to pitch or sell your product. I think that's the question.
Yeah, this is it's a really good question, and you're never going to say your AI is very flawed, right? And it has to be it has to reach some level of accuracy before you try to sell it. But people are it. I deal with that every day because I always have clients that come up to me and are like, "Well, this does not work as I hoped, and it's taking too long for it to learn with my patterns of use." And I try to tell them it's not that it's very flawed, but I try to tell them like, well, what we do is, for instance, in our company, we match job descriptions with CVs, and we order people that have more to do with those CVs on top of the list. So HR managers will see like the more adherent contenders, like for that job opening. We do not eliminate anyone or anything like that, because that would be like going over the person. But we order the people we think it should seat first. Otherwise, a lot of good people that are adhering to the job opening end up not being seen, because people only see like about 20% of the CVs that are sent for a given job opening. But then I tell them like, well, it doesn't matter what you write, example, in the job opening description, because the AI does not consider that. The AI considers prerequisites. If you do not give examples of like daily activities, for example, the person uses a lot of, I don't know, Microsoft Office, and the person will use C#, and the person will use AWS. I won't be able to give you accurate descriptions, So I tell them like, how can I give you the best descriptions possible? And then this sets their expectation. For instance, too, we have a lot of clients that they open vacancies for operational jobs, which is really common in Brazil. We're very labor intensive because we don't have a lot of automation here. So, and they're like, well, we have nearly no prerequisites. We usually just want people to have finished high school.
Yeah.
And I tell them like, I will never be able to give you like great matches because there's not enough information. Like the AI is not a telepath.
No.
Like it does not know everything, but like if it probably will never work. And I tell people that like I'm really transparent. Like we probably will never work right for operational job openings. But if you have like more specific, more skill intensive job openings, and you describe it right, then we can work together and we can build on that, and then it will give you best answers. Will give you like a better ordering of your candidates. So it's like you have to say. I think like in the end, like to summarize everything I'm saying, is just like what is my AI taking into consideration, and what are the main traps, And people understand that. It's like if they see sense, I have a good I have a good rapport with my sales team, and they're happy to explain, well, this it's we're not able to do, this we cannot do, but if we do this right, we can bring you these types of results, and people understand. So it's not like, well, my AI is very flawed and we have this really huge problem, will never work. But it's like, well, we have to work together doing things like that, because this will be taken into consideration, and I will give you these types of results, and then you show people the results you've already gotten, and then they're willing to try. They're far more willing to try when they see that it's possible to get there. We have clients with like 10,000 candidates in a position, which are really huge industries in Brazil.
Mm-hmm.
And people will always hire the top 10 in the order factor, because they know it works. So I can show them, like, well, 91% of our clients hire people that are in the first page of results. So it's not Google yet, but it's pretty close. So people are like, wow, I can use that for myself. But 91% will never be 100%, And we know that, and we tell them that. So I think it's just like establish this really transparent connection and relationship with your client, and explain where you're taking the data from or how you're making the decisions.
Yeah, I agree with you. I don't think like setting expectations and being transparent is necessarily bad. So I think that takes a place. I agree. Great. I think this is our last question, because we're almost hitting 1 hour of live stream. So what sort of future roles do you foresee in AI development teams that specialize in this sort of design? And do you think this allows for more women in AI?
This is an interesting question too, because maybe it allows for more women in AI because we have a lot of women in design, but like women, I don't know. Women are welcome in AI, and women will thrive in any field, right? Like, so like having said that and having taken that out of the way, maybe we'll have more women related with AI because we'll have different expertises, which tend to be, at least for the moment, tend to have more female representatives. I don't know, but we're going to have a lot of future roles. There are some I really like, which are AI ethicists, for instance, is like, what I'm doing with AI, how does it affect society? And then I have to see how it affects society and the backlashes and the repercussions something might have, So this is a new position that people are opening. But if you go on Google and type AI ethicist, you're going to see that these positions already exist. They're very rare, but they do exist.
Yes.
We're going to have a lot of something like I do, is like a product manager for AI, which is different than a regular product manager because AI is very research intensive.
Mm-hmm.
So we're going to have a lot of people that are working in companies, but they have to have these research feel, they have to have this kind of good rapport with research. And this is a little different than your usual or your typical product manager. We're gonna have a lot of designers that specialize in AI because this is something I've learned in a practical way. Usually designers, like for software systems, they're trying to work on usability and experience, but usability has a lot of like lowering cognitive load, like things people don't have to memorize, things people can do intuitively. And for AI products, the main challenge is to be able to explain in a proper way, So this opens up huge opportunities for designers to specialize on AI usability, which has a lot to do with how can I explain something and content that is really complex. We've tried to do that with our platform at Guppy, and we opened a highlight section that tried to explain which parameters the model took into consideration to the ordering or to boost someone's score. But sometimes it's like we would say, well, this person went up on score because it did really well on tests. And then the highlight would say good test results. But the test result was really bad. It's just that everybody else was so much worse, you know? So
yes.
this also causes a lot of like people do not understand. It's like, well, why did you tell me it has good results? Because, and it's like, well, it has good results comparatively with everybody else. So it's still a good result. But people don't want that, especially in HR. People want like, well, we if you get a score that is lower, I don't know, below 60, I'm going to cut you out of the process, you know? So it has a lot of like these nuances, which are really hard to get right. So yeah, we have a lot of space for that. We have a lot of space for people to analyze data and like to previously filter and see data quality, which is something that people say, I know, but data scientists do that. But usually they don't. Usually they're too busy like just taking data and like making models. But we would have to have someone checking like for data representativity and for data accuracy, and how can I bring more data with quality for that? You know, it's like some kind of data analyst and data searcher. I think this is also a new opportunity for AI. And yeah, I think there are a lot of other things we can bring here, but like these are clearly things I see that are new and that open up a lot of opportunities. And maybe it will be like a slow way of bringing more women to the AI field if like those areas are more women intensive than the others. But that's the only reason why, I think.
Yeah, I agree. Yeah, sometimes people are afraid people in general are going to lose their jobs for AI, but at the same time, you create a lot of new roles also. So that was nice to hear, I guess. So I think that was our last question, and we are a little bit more than 1 hour. And so I would just like to thank you again, Bianca, for giving your time and sharing your knowledge with us. And before we leave this presentation, I have placed here on the screen a link to the feedback form. So if you like your presentation or not, you can give your feedback to us, and so we can improve for the next events. And thank you so much for everybody who participates, sent questions for us, and see you in our next event. Thank you so much. Thank you, Bianca.
Thanks, guys. Thanks, everyone. And like, guys, if you have still questions, which I see there are some questions we haven't answered,
yes.
some others by Sam, you can reach out to me on Twitter. I think it's like the girls will send you my handle, but it's Bianca BQ at the end, and then you can shout out there, and I'll talk to you.
Yeah, we have a Discord channel, so we can continue the discussion there. We can send your handle indeed, and then people can contact and network and everything over there.
Great.
Thank you so much.
Thank you so much for having me, and have a nice day. Bye-bye.
Have a nice day too. Bye-bye.